Okay. Can you see the screen?
Yes, sir.
Okay. So this is your lab 2.
Sir, can you make it landscape?
So this is your lab 2. Mhm. All of you have finished lab 01. So this is section C and section B. You missed one lab. Okay. So for these two sections mainly, we'll take this lab today online. And section A will have the class on Tuesday. Okay, on Tuesday. Achha. Now, in the first lab, lab 01, in lab 01, we saw how to create a CNN architecture. Okay, very simple CNN architecture using TensorFlow. Okay, so I believe by now you actually understand how to create a simple architecture and how to train a simple architecture in CNN using CNN. Now, in lab 2, we'll try to go a little bit deeper and try to see the output from different other operations. Before going there, I want to go back this lab 01 again because the lab 01 that I showed earlier, I updated the notebook and that was also uploaded in your Google Classroom. So let's look at this one first and then move on. Okay, so let's see. Can you see this see the screen? So here. Come on. Okay, can you see this screen?
Yes, sir.
Achha, so this was your lab 1. So you already see these things, but I actually separate different things out. I am just going to show you the output. So to summarize what we actually learned previously, first, you start with importing the libraries, necessary libraries that you have. Then the data, we use the Cypher10 dataset. You can work with any other data. This data is already available in TensorFlow, so we use that one. It's a very small dataset and a small sized image, only 32 by 32. Because this image, after the class, you already understand how different parameter calculation actually work, how many parameters that you need. So all the sections actually, it is covered in all the sections. So you know, if the image size is very large, like if the image size is 1000 by 1000, your number of parameters will increase because that will actually be determined by the number of filters. So that will be multiplied. So if you have large size image, your calculation, the number of parameter will be larger. So you need to reduce the size of the image. But here you see there is only 32 by 32. That is also already very small. Okay, so you don't need to reduce this too much. So you need to go it slowly. That's fine. There are 50,000 image. Okay, in the test case, you have 1,000, 10,000 image. And these are the categories. This is some of the pictures, not a very good quality. Pictures are not very good quality. Then the CNN architecture, we just first normalize the pixel values. That's fine. And this is our CNN architecture. So very simple. This was our version 01. There are different versions I have created so that you can actually understand the difference, how everything is changing. So in this first version, you have one convolution, one max pooling, one convolution, one max pooling, then flatten, then dense and dense. The output is 10, so that's why you have 10. There are 10 different output categories. That's why we have 10. I believe you already know these things. I'm just going through it just a little bit. So model V1 summary, you can see this is the parameter 896. And you know why this is 896. Okay, this is coming from the this one, 3 by 3. So 3 by 3, that is multiplied by the multiplied by this one. And then you have max pooling. So it does not change the parameter size, but the shape is reduced to 16 by 16, and this is the number of filters that you have. Okay. Then you have this. In the dense layer, you can see the most of the parameters is coming from after flattening, this dense layer. So 4096 is multiplied by this one, plus 100 for the number of bias term. So you see the total number of parameters is here is 430. Okay, around 400,000, more than 400,000. And there is no non-trainable parameters. All of them are trainable. So when you train it, you can also view it like this way. Then you can train it. And this was one of the issue, epochs, number of epochs. What should be the number of epochs? And in the class, we have discussed that if we increase the number of epochs, okay, it can overfit. So one of the solution of that one was callbacks. Okay, we'll see the effect of callbacks today. In today's lab, we'll see the effect of callbacks. So here it has been trained for all the epochs, and the training time is very small. And one other thing you see, you see that there are, for each epoch, there are 50 epochs. For each epoch, there are 1563 steps. Why there are 1563 steps? Anyone? Why there are 1563 steps? Anyone?
Sir,
Why is it?
are those batches of images?
Yes, that they are batches. You see, this is that mean in one epoch, the weights and the parameters are updated this number of times. Why this number of times? Because you see, originally there were 50,000 images in the training, right? 50,000 images. So if I divide 50,000 divided by 1563, right? So what is the size? 32 almost. Because by default, the batch size, we did not mention it specifically. So by the default value of the batch size is 32. So for each batch, like mini batch size, so under one epoch, there are total 1563 batches, where in each batch there are 32 images. Is it clear? We need a board.
Yes.
So actually board স্যার আমি just বলে যাচ্ছি, তো বুঝে নাও একটু, যেহেতু বোর্ড নাই বোঝাতে পারতেছি না, লিখতে পারতেছি না। সো তার মানে হচ্ছে আমার টোটাল 50,000টা ইমেজের মধ্যে আমার 1563টা ব্যাচ আছে, মিনি ব্যাচ আছে। আমরা মিনি ব্যাচ করে ট্রেড করবো। সো প্রত্যেকটা মিনি ব্যাচের জন্য একবার করে ওয়েটটা আপডেট হবে। সো একটা ইপোকের মধ্যে 1563 বার ওয়েটটা আপডেট হচ্ছে, এবং প্রত্যেকবারই একসাথে 32টা ইমেজের ওয়েট আপডেট হচ্ছে। ঠিক আছে, 32টা ইমেজের উপর আমরা হচ্ছে গ্রেডিয়েন্ট ডিসেন্ট খাটাচ্ছি। ওকে, so you can see the loss accuracy and gradually lower. So that's it, and you can see this plot. You can see the model is actually overfitting. By the time you reach 50 epochs, the training accuracy is almost 100%, but the testing accuracy is not actually increasing. It is just keeping one. So after certain region, you can say after 5 or 10 epochs, your model actually starts to overfit. It is not learning anything. Okay, the training accuracy keeps increasing and increasing and increasing, but validation accuracy does not change. That means your model is not learning, so your model is actually overfitting. Okay, so training after this portion, like after 10 epochs, is just useless. Your model is not learning anything. So that's actually useless. So it's very important to use a callback to stop there. Okay, to stop the model from overfitting. Now, the same thing for loss. So if you go to model version 2, in the model version 2, we make the model a little bit deeper. Okay, we put 4 convolution layer, 4 max pooling layer, and so on. And you can see from the size, if you see from here, 32 by 32 max pooling, it becomes 16 by 16, and gradually towards the end, there is only 1. Okay, this is not actually a good architecture. This is not actually a good architecture. Why? Can you tell me why it is not a good architecture? What can be the reason?
We are losing all the features.
Informations
That's
are
why.
lost.
আরেকবার বাংলায় বলো, সমস্যা নেই।
So we are losing all the features and everything depends on just one cell.
আচ্ছা, আরেকজন, আর কেউ?
But since the image is converted to just 1 pixel, so we are losing various features of the images.
What do you do in ResNet? In the ResNet, in the last layer, what is the image size becomes in the last layer? মনে আছে? After we use the global average pooling,
Yes,
কি
sir,
হয়ে যায় global average pooling এর পর
sir. একটা
1 হয়ে যায় না?
হ্যাঁ 1 হয়ে যায়, স্যার।
আচ্ছা, there are actually two things. So let me write here. অনলাইনে ক্লাস নেওয়া একটা মাথার কাজ। আচ্ছা, see, when you have this architecture, there is a like a certain approach that we actually tries to follow. What are those approaches? See, gradually, as we go deeper, okay, as we go deeper, we want filter number of filters increase, image size, feature map size decrease. So you see, initially our image can be 1000 by 1000, and we are gradually reducing the feature size, image size. Okay, using our max pooling and other things, we are gradually reducing it. So image size is reducing. But you see, in the third dimension, we are adding the filter. So let's say 32 filter, then 64 filter, then 128 filter. So if you look at the standard architectures, you will see as the model gets deeper and deeper, the number of filters keep increasing and increasing. 512 filter. Why? The idea is, so let's say here we have only a 7 by 7 and 512. The idea is towards the end, the information, the feature information, we want each of the filters to capture one information, one feature, particular feature. So the filters is going to capture the features. So each filter will capture one one critical feature, like this way. So though when we go deeper, we want to increase the filter size because the information that we are looking for, the feature that we are actually looking for, that should be inside here, that should be in this dimension now, in the filter dimension. So this is reducing, but you see what the filter is doing at each step, the filter is actually passing through the image. So the filter is actually learning different patterns. Okay, so this filter is now will capture whatever the pattern we try to learn. So this one will reduce, this one should increase. That is one thing. Okay, that is one issue. And you will see, I'm going to show you. So this rule has been break in that second version. That is one thing. Another thing there was, that is actually in the final one. Let me show you first. So you see, এখানে কি করতেছিলাম, 32, 64, 64, fine, 128, then you are reducing to 64 again. Can you see it here?
Yes,
So
sir.
this is actually unnecessary because it should not be like this way. When you reduce the image, that's fine, but you should increase this one. That is number one. Number two, usually we do not reduce it to 1 by 1. Okay, we try to keep it like a small feature space, that's fine. Usually try to keep it to some value, 4 by 4, 8 by 8, that's fine, not too large, but not 1 by 1. Okay, we usually keep it to some value. That is one thing. And here you can see after first flatten, when you flatten, what is the number of, after flattening, there is 64 neurons, right? 64 values there, 64 pixels. Now from this step, we are increasing the dimension. From 64, we are giving it to 100. Then again, keeping it to 10. We usually do not go this way. We gradually reduce the dense layer size. So if we have 65 parameters, 65 features, so this is the 64 features now. After flattening it, these are the 64 features. This is going to learn by the neural network that we have here. So we usually put the 64 to some lower dimension. Okay, I want to reduce the size of the architecture gradually. So if I show it here again, screen now. So the idea is, if I have 64 values here, 64 features here, in the next layer, it should be reduced. It should be like this, smaller. It should go smaller. It should not get wider. From here, I should, in the next layer, it should go even lower so that I can gradually actually extract the images, extract the feature, most critical features. I don't want to expand it anymore. Whatever was important here, I want to reduce it now. I want to reduce it further. Then finally, I have, let's say, 10 one, the last one. The last one will predict. So gradually reducing it this way. Okay, it should not be like this, not this way. This is not actually desirable. This is the structure architecture. We gradually make the size smaller and smaller so that the information, the feature information gets much more important information are actually captured gradually. Okay, that should be the standard architecture. Is there any question? Am I able to explain it properly?
Yes, sir.
Acha, so so if you look at this code, you can see this will. So when you do it, the number of parameters will reduce, but that's not what you want. So this, and you can see if you look at this one, there is only a small improvement in performance. Okay, but making the model 7-layer deep did not provide desirable improvement. Okay, previously we had only 2 convolution layer. We made it to 7, but still the model is almost performing the same. Okay, there is not much improvement. So you are not actually doing anything, making the model just deeper. Okay. So just making the model deeper is not enough. There are many other things that you need to do. Okay, we'll look into these things one by one. I hope this is up to this point. This is the architecture that you should actually follow. Okay, I hope this portion is clear how we actually create a CNN architecture. So keep track of those things. So now, so this one, effect of changing the batch size. Previously we saw that we use a batch size that was actually by default 32. Okay, now let's change it. Okay, let's make it 128 and see the effect. If we change it, you can see now in the feed version, there is another parameter batch size 128. So we have made it 128 now. That means inside one batch, there will be 120 image. So 120 image, the weight will be updated simultaneously. Okay. And when you do this way, you can see the number of batches inside one epoch, it has been reduced 391 now. Previously কত ছিল?
1563.
হ্যাঁ, previously ছিল 15,000-এর মতো, 1500-এর মতো. Now you see, now we are using a batch size of 128. So now only 390. So 391. So inside one epoch, there will be only 391 times weight update. Okay. So when the batch size is increased, so number of times weight update has been reduced. So the time is reduced. Now you can see it is 5 seconds, 3 seconds. Previously কত ছিল দেখছিলা? 8 seconds and 9 seconds. Okay.
4
Previously it was,
milliseconds.
হ্যাঁ কি বললাম?
কম ছিল।
হ্যাঁ হ্যাঁ, গতবার ছিল 8 সেকেন্ড এন্ড 9 সেকেন্ড, বিকজ তখন আমি প্রত্যেকটা ইপোকে আমার স্টেপ ছিল অনেক বেশি, 1563টা। বাট নাও এখন আমরা যখন বাড়াই দিচ্ছি, তখন আমার স্টেপ কি কমে গেছে না, 3 সেকেন্ড হয়ে গেছে। সো আমার প্রায় কি পার ইপোক দ্যার ইজ লাইক 6 সেকেন্ড টু 5 সেকেন্ড আমার কমে আসতেছে টাইমটা, তো কম টাইম লাগতেছে। আসসালামু আলাইকুম, কে বলছেন? ও আমি ক্লাস নেই, ক্লাস। হ্যাঁ হ্যাঁ, বাসে। আচ্ছা আচ্ছা। নাও you can see after when we actually increase the batch size, it is the training time is reduced. So when you have like lots of images, if it's like 50,000, when you have lots of images and it is taking too long to train, you can increase the batch size. Okay. And usually we try to keep it like a multiple of 2. So you can use 128, 256, 512 like this way. So if your like data set is very large, so make it instead of 128, make it 256. That's fine. Now you can ask, when you do that, will there be any effect on the accuracy? কি মনে হয় accuracy effect পড়বে?
Yes, sir.
Acha. Now the effect on accuracy is actually very smaller, not very larger. You can see the effect on accuracy is actually very slight. Okay, this is not much different than the previous one. If you compare between these two, it is almost the same, almost 70%. So there is not actually much difference. So changing it from 64 to 128 will not have a huge difference. Yes, it can happen that if you have 32 to 512, there will be some difference, but like 64 to 128, there will not be like severe difference in between the accuracy. But your training time is almost like অনেক বেশি কমে যাচ্ছে, 50% reduce হয়ে যাচ্ছে. So it's a very plus point. So if you have to like sacrifice a little bit of accuracy, like 1% accuracy, that's fine. But your training time is now more reasonable. So when you're training using GPU, sometimes it might take 10 hours and 12 hours. It is taking too long for you to train. You can increase the batch size to make and to make the time actually reduce the time. But one problem is that it will take more space, okay, more memory space. And when you are training using your laptop, like your PC, your GPU, your own GPU, usually the RAM available in those GPU is limited. Okay. The VRAM that is available, I think it is 6 GB or 8 GB. You have GPU, like if you have 36 GPU, but the RAM that is available to you is limited. But in Colab, you have large RAM, large space available. So you have to have some balance between these two, okay, when you try to train this kind of CN. Acha. I think it is clear. Any question? Okay, no question.
No.
Let's go to version 3. Now this is your modified version, and you can see what we did here. You can see now I actually, when padding, when max pooling, I'm using strides of 1. When I'm using strides of 1, the image size is no longer changing. You know the calculation, you can calculate it how. So I am reducing the image gradually, but not every step. So now I have the same max pooling, but you can see in the last layer, I have 4x4. And I'm gradually increasing the 32, 32, 64, 64, then 128, gradually increasing the filter size. Okay, so this will increase a little bit of the number of parameters will increase, that's fine. But you should follow a standard architecture. So your version 3, you can say this is a standard architecture that you should actually follow for creating your CNN model. So if I go below, so I'm using 64. And now you see now the number of parameters has increased. So now it is taking 6 seconds. Fine. But still, you see, validation accuracy, not that much, only slightly. 70, I think the maximum you got is 67, 60, 73% around. Previously, it was 62%, 62, 61 like this way. So 1% increase, not that much. So the model is actually still overfitting. So you have to have some additional thing that you need to do. Okay. One of the things that you have learned to actually get out of this kind of scenario, overfitting scenario, was regularization. And one of the common regularization technique is dropout regularization. So if you look at this one, this is your dropout regularization. You already know what dropout regularization is. It was covered in your classroom. Now you see, I'm using this dropout with a percentage of 0.2. That means 20% of the nodes will be omitted. Okay, you can make it 0.2, 0.3 max. Usually 0.2 is the common one. Sometimes 0.5 I've seen, but 0.2 so far I have read. 0.2 is the standard approach, and you don't need to do it for each of the after each step. Okay, you can add 2 or 3. That's fine. Okay, you don't need to do it too many. So dropout, I think have 3 dropouts. Okay. So same architecture, I have just added some dropout layers. And then I have the summary. And when you see this dropout layer, there is no parameters. So dropout does not add any parameters, does not change anything. Okay. And same number of parameters, then training. I think training time has increased a little bit, 7 seconds, right? So when you add a dropout, training time should increase a little bit. Okay. So now you can see there is 7 seconds. Previously it was 6 seconds. I think only the thing added was the dropout layer. So there is only 1 second difference in the training time. So adding dropout should increase the training time slightly. Okay. Now we can see it is now 78%. Okay. You can see the maximum we reached 78%. So there was like a 5% increase. Okay. And also you can see this training accuracy, it is now around 90%, 91, 92, like this way. It is no longer 100%. Previously, if you remember in the previous scenario, previously it was 100%. Training accuracy was very high. But now, after I add this kind of dropout regularization, you can see now it is 92%. Okay, 92, it is 78. So training accuracy has reduced, validation accuracy has increased. So the difference has been reduced. So you can see pretty clearly that adding dropout regularization is actually helping you reducing the overfitting problem. Is it clear?
Yes, sir.
Any question?
Sir,
Okay.
I have a question.
Yeah, of course.
Sir, why are we using those pooling layers where they are not reducing the size? Because we use pooling layers to reduce the size further, right?
Yeah. For here,
So,
in this one,
so
in this one, what actually why I'm actually not reducing the size is because my original image size is only 32 by 32, right? My original image size is already very small. So I am
yes,
keeping this one just to show you the standard architecture, because after each convolution, we actually give a max pooling layer. But here you see this 32 by 32, after this 32 by 32, if I keep reducing it, it becomes very small within this, after 4 or 3 convolution layer. If I keep this max pooling layer again and again, it will become 1 by 1 very quickly. So that's why I have kept that one similar to the previous one, just did not reduce it. You can omit this one, that's fine. It will do the same. Okay. You can
I
complete.
mean, if we just if we just omit the max pooling layers, it shouldn't affect the architecture, right?
It should not affect node like this way. So you see, when I put this one like this way, stride 1, that means I'm putting, still I'm getting the max, right? I'm still pulling the maximum value. But now I'm doing it in such a way that my image size is not reducing, but I am still getting the maximum from each 2 of the, instead of 4, now I'm getting max of 2 on average. তাই না? আমার যে আগে
Yes,
কি
sir.
করতেছিলাম, আমরা 4টা থেকে
Yes, sir.
ম্যাট্রিক্স দিয়ে 4টা এলিমেন্ট থেকে আমি 2টা একটা করে নিচ্ছিলাম। এখন যখন ম্যাক্স পুলিং করতেছি, আমরা কিন্তু স্টিল নিচ্ছি, কিন্তু আমরা ওটা অনেক ফ্রিকোয়েন্টলি নিচ্ছি, যে সেই কারণে আমার হচ্ছে সাইজটা চেঞ্জ হচ্ছে না, কিন্তু স্টিল কিন্তু ম্যাক্স পুলিং কিন্তু একটু কাজ করতেছে, তাই না?
Yes, sir. Yes.
বুঝা গেছে? সো দ্যাটস
Yes,
ওয়াই
sir.
আই কেপ্ট ইট, ইউ ক্যান অ্যাকচুয়ালি omit it, দ্যাটস ফাইন। আচ্ছা, এনি আদার কোশ্চেন? ওকে, সো in your lab, I would ask you to train one by yourself, but since now we are doing it online, you can actually omit this portion. এখানে ছিলাম, তাই না? হ্যাঁ, this one. আচ্ছা, let's go to this one. So you can see after we are done with dropout regularization, our performance has been improved by 6 to 7%. Okay. Now, batch normalization. So we also talked about batch normalization, that it is something you should do to actually make everything in a to make the values normalized. Okay. And this is also another kind of regularization approach. And you should actually have some batch normalization there. Okay, it makes the training process much more like much more simpler. Okay. So you see, after first convolution, I put a batch normalization, then drop out another batch normalization. So you can again, don't have to put it everywhere. You can put a few of them throughout your architecture. That's fine. So after this batch normalization, you can see when I put this batch normalization, it adds some parameters. 128, okay, 256, 800. So when you put this batch normalization, মনে আছে batch normalization কেন additional parameter add করে? কেন প্যারামিটার অ্যাড করতেছে ব্যাচ নরমালাইজেশন? এনিওয়ান? এনিওয়ান? ক্লাসে পড়েছিলাম তো, ভুলে গেছো? সেকশন বি কে পড়েছিলাম। কুইজ নাই তাই পড়াও নাই।
Please, sir, what is the question?
Question is why batch normalization is adding parameters there? How? You see after batch normalization, 120 parameters, 128. Batch normalization, 256. Where this parameter is coming from in batch normalization? Tanvir বলতেছে scaling and shifting. Yes, batch normalization actually performs two tasks. Okay, additional task after normalizing. One is scaling, another one is shifting. Okay, so when you have this batch normalization, it adds two additional parameter. One actually for scaling the values and shifting the values. Okay, this was taught in the classroom. So two parameters is added for each and every one of the step. And alongside these two, okay, alongside these two, they actually have some other parameters. Those are non-learnable. These two parameters are learnable, and it also have some parameters that are not learnable inside for actually making the training process smoother. Okay, so like the variance and the mean value, other parameters, that's something we do not learn. It is inside the values. That's why you have some non-trainable parameters here. This is the first time you having this non-trainable. If you look at your version 4, okay, you see there are no non-trainable parameters there when you had this dropout. After you add this batch normalization, it also has some insight. It has some parameters that is not trainable. Trainable means তোমাকে ওটা network থেকে learn করতে হবে না. That means that they do not learn those things from the network. Okay, so batch normalization have some non-trainable parameters as well as some trainable parameters. Okay, so that is your size now. That is your parameters, and if we train it, you can see same way, same epoch, same batch size, and we are training it. Now, now you can see the training accuracy is now 95% and the validation accuracy has increased. It has now 81, 82%, almost 81%. Previously, it was only 78, I think. It was 78 max, around 78. Now it is now 81%. So after adding batch normalization, you can see your training accuracy has reduced, obviously, like previously, and validation accuracy has improved. Okay, your validation performance is improved to 81%. Okay. Acha, so that is the effect of batch normalization. Same thing as validation loss. So you can see the effect of batch normalization here. So these are some of the things that you actually should add in your network. Okay, you should add some, besides some standard CNN architecture, you should add some dropout regularization. You should add some batch normalization layer. In the next, we'll see something more. Before you go there, you can see whatever the prediction you make, you can also plot it. Okay, so just take the image and just plot it. Okay, Achha. So there is a function that says predict. Achha. There was an error. You can see what is the error. If you directly try to predict it from the test image, it will show an error like this way. It is saying that the input layer sequence is incompatible with the layer size because the expected shape is none 32, 32, 3, and the found shape is 32, 32, 3. Where is this none value is coming from? This is expected, right?
Sir, is it the batch size, undefined batch size?
Not batch size, actually, the number of image, actually, image size. So, see, when you have initially, if you remember to, if we go at the start, you can see this is the training and test shape, right? That is, it's a 4-dimensional vector, 4-dimensional array. The input shape is 10,000, right? 10,000, then this one. That means there are 10,000 images there. 50,000, that means there are 50,000 images there. So the model, when you actually use this predict function, they also expect a 4D array. when you put, like when you try to test for one single image, so you don't have this information there. You're just putting this one. Okay, that's why it is giving you an error. It is throwing an error. So what do you have to do? You just have to put a one there. Okay, so you see, I just reshape it to one, just add one, because we are testing it for one value. And now you can test, you can see the prediction value. Is it clear? The input, when you are testing the predict value, they expect that the input will be a vector of a array of 4-dimensional array, where the first dimension will be the number of images. There should be 10,000 images like this way. But when you are doing it for a single image, you should add that there is only one image, then it will work. And you can see when you predict, it is giving you an array, output array of something like this. What is this? How many values are there in this array?
10.
10. Why 10?
For each output, each
For each-
category. So
Yes, for each category. Okay. There are in total 10 different categories. So that's why it is giving you, the softmax is giving you the probability.
Probability, sir.
Probability for each of the classes. Okay. And you just have to take the maximum of them. What is the maximum category? So if you take the argmax function, it will give you the one. And you can see array 9, the last one, it is giving you the minimum, maximum probability. All of them are e to the power minus 10. That means very small probability. And this one has the highest probability. So this image should belongs to the last one. What is the last one? Track, right? So this is actually the image of a track. Okay, so this way you can actually plot the predictions as well and see how your model is actually performing. Okay, any question? Any question? So this. So this was our lab 1. So from our lab 01, now you know how to create a CNN architecture. Okay, now you know the effect of dropout regularization. Now you know the effect of batch normalization. You also know how to visualize output, how to show the output. Okay, the output probability and how to actually show. So this was your lab 01. Now in lab 02, we want to extend a little bit further. And by this lab 02, I want to finish this CNN, how to actually build a standard CNN architecture. So I'll show you several notebooks. Now, number 5, we'll start with callback. Okay. And in the callback, section B actually has covered callbacks. Section A and C, you have not covered callback. Now, to summarize callback, you see, when you start training, the scenario was like this. Our training accuracy was keep increasing like this way. But validation accuracy actually flattened here. So when it is like this way, you can see the model actually starts overfitting from this region. After then, validation accuracy is not increasing, but you are keep training. So this is just waste of time. This is just waste of time and resources. If your model is not learning anything, that means the validation accuracy is not improving. That means your model is not learning anything. So training is useless. Okay, you have to change your model. If you keep training, it will only overfit more and more. So this is actually overfitting. So when you have this scenario, and you also don't know how to actually how to fix the number of epochs, how many epochs do you need prior to training, you have no idea. So in scenarios like this, we use this callback. I will discuss more in the classroom. There are different callbacks. There are like around 10. The one we are going to work with, that is called early stopping callback. Early stopping. If you look at the TensorFlow documentation, you will see what is early stopping callback. So in early stopping callback, what we'll do is that we check the validation performance. We check the validation performance and see, let's say for 5 epochs, this is you can change. You can make it 10 epochs, 15 epochs, whatever you like. For 5 consecutive epochs, if you see your validation performance is not increasing, okay, it is remaining almost the same. In that way, that means your validation performance is not increasing, then you stop training. Okay. If it is like this way, you just stop. You don't go any further. So that is the purpose of early stopping. Just like the name says, we stop training if your validation performance does not increase. Okay. So that will stop the overfitting region. So your model will stop here. Done. আর কিছু আগাবো না. So that is one callback. There are other callbacks as well, but this is one we are interested in right now. So you can try with other callbacks. So let's see. If you go to TensorFlow API. So TensorFlow.keras.callbacks. So you can see TensorFlow.keras.callbacks. And if I go to the overview, you see there are different callbacks. Okay, these are the classes. That means every one of them is one type of callback. And you can see there is my earliest stopping callback. Okay, there is learning rate scheduler. Okay, model checkpointing, this is commonly used. Reduce LR on plateau, then tensor board. There are different callbacks. You can see their functions by yourself. Now let me show you this one, how to use a callback and its effect, earliest stopping callbacks. No, not here. Okay, so CNN model without callback. I think this is the same one like previously. 128. Here, I just increased the batch size to 128. And this was my performance. Training accuracy was 95% with batch normalization, as well as if you look at the architecture, I have batch normalization, I have dropout everything. I have dropout batch normalization. So this is the standard architecture that we actually formed. Now we are coming to this region. So you can see my training accuracy is increasing, going to 95, almost 95%. But validation accuracy is almost same. It is not increasing that much. It is going to 80%, then almost flatline. Very small increase. So if we want to add a callback, you can see there are different callbacks. So we'll do it like this way: TensorFlow.keras.callbacks dot is early stopping callback. Okay. If you look at here, early stopping, this one. Achha. So you can see if inside in the early stopping, the monitor, what we are monitoring, validation loss. Okay, that's the default one. You can put any other things as well. So the standard approach is that we monitor the validation loss. Okay, and you can see patience here. Patience means how many epochs should I actually look at? And you can see the description here, every one of them. Patience, number of epochs with no improvement, after which the training will be stopped. So this is something you have to change. Okay, you can make it 5, you can make it 10. Usually 5 to 10 is enough, not 1 or 2. Why not 1 or 2? কেউ বলতে পারবে? কেন 1-2 ইউজ করবো না?
পার্সেন্ট তো অনেক বেশি থাকে।
বুঝিনি, আরেকবার বলো। Why should use patience of 5 to 10, not 1 and 2?
স্যার 1-2টি পোক দিয়ে তো তো বোঝা যাবে না, মানে নাম করার জন্য টাইম দিতে।
You see our validation loss, if you look at this one, this is always fluctuating, right? So in one epoch, it is like very high loss. Next epoch, it is reduced. So this actually fluctuates. So if you just look at 1 or 2 epochs, that is not enough to actually give you a good idea. So you should actually look at 5 epochs or 10 epochs. That after it's like consecutive 5 epochs, you have no improvement. And then you say, okay, stop. If you just look at 1 and 2, then you will actually stop very early. That will actually not train properly. So you should have some, like, you should have some patience. Okay, add some patience here. So 5 patience. Okay, then early stop, you just define it outside your model. So you define it outside your model, same architecture, same thing. And in the fit function, you can see there is a option callback. In the fit function, there is an optional parameter that is called callbacks, and you can just say earliest stop. Okay, that is how we define this callback, earliest stop. You can also add multiple callbacks at the same time as well. Okay, you can have another callback like model checkpointing or TensorBoard to check the parameters, how they're changing. So if you do it this way, you see our patience কত ছিল 5, right? Now, how many epochs did it train? কয়টি epoch train করছে?
17.
17. So out of 50, so initially I said 50, it only trained up to 17. It did not train further. So you can see the maximum now 89% and 78% or 79%. It stops training here. It doesn't reach 85%. Reach করছিল last time এটা 82%. এটা কিন্তু 82% পর্যন্ত যাচ্ছে না. So it is stopping this training 79%. So why it is good? If we keep training, তাহলে তো আরো ভালো হবে, তাই না? If we keep training, validation accuracy might increase to 82%. Then why should I stop at 79%? কেন বলো? বলো বলো বলো। Anyone?
ওভারফিটিং এর জন্য নাকি?
জোরে একটু জোরে।
Overfitting.
Yes, if you keep increasing, you see your validation accuracy will increase, yes, but your overfitting is increasing as well. Overfitting increases means, now if you take this model and test it on a real world scenario, you are saying your model performance, validation performance is very good. You are hiding this one, the overfitting. You are saying that validation performance is 83%. But when you're testing it on a additional data, external data, okay, then you will see suddenly your model is not actually performing very well on real world data set. It is failing. So that's why you don't want your model to overfit. Okay, that is more serious problem. Even if your validation accuracy increases, no, you should stop whenever your model starts overfitting. You should not go that far. So that's why early stopping callback is a good approach. Whenever your model starts to overfit, you just stop there. Okay, so now you can also do one thing, like there is another callback, that is model checkpoint. Okay, in model checkpoint, it actually stores all the weights after each epoch. Okay, so you can say I will keep it up to this one after, let's say, 11 epoch, because in this point I think we have the highest accuracy, validation accuracy highest, this one. Okay, you can say, okay, I will just keep it up to this one. You can do this. You can also do it this way using this model checkpointing callback. You can try it by yourself. So that is the purpose of callback. You stop the training. So your model is no longer training for 50 epochs. So you stop just 17. So training time is reduced. Okay, you are training it for very smaller time. And whenever it starts to overfit, you just stop your training. Now you can see the loss of validation loss and accuracy is very closer. Okay. So give it a try try the other epochs by yourself, other callbacks by yourself. And I hope this is clear. Any question regarding this callback?
স্যার চেক পয়েন্ট কলব্যাকটা কি ট্রান্সফার লার্নিং এর জন্য ইউজ করেন কি?
চেকপয়েন্টটা, মডেল চেকপয়েন্টটা তুমি নিজের জন্য ইউজ করতে পারো, ট্রান্সফার লার্নিং এর জন্য ইউজ করা যায়। ঠিক আছে, ওটা পারপোজটাই হচ্ছে ওটা। মডেল চেকপয়েন্ট হচ্ছে তোমার ওয়েটটা স্টোর করে রাখা। ওকে, এটা অলওয়েজ করা হয়, মডেল স্টোরটা অলওয়েজ স্টোর করে রাখা হয়। তুমি যখন একটা, like when you are actually training a real world, training your model on a real world data set, you want to store your weights. Okay, you don't want to like forget it. You want to keep it wherever you actually, whenever you're training it, whatever the weights that you have found, because you are training it for 12, 20 hours, 15 hours. You don't want to lose your weights. So whatever the weights that you actually found, okay, you want to store it. So that's why you want to keep it in model checkpoint. Okay. Any other question? আচ্ছা, so this one is done. Share screen stop. So you saw what is this callback and how early stopping, why we need early stopping, and you can try to work with other one as well. Number 6. Acha. So now you see, previously we have seen some of the architecture like the VGGNet architecture, okay, VGG16. And from this one, you know how to actually create a VGG16 architecture, right? You know how to put a batch normalization, you know how to put a convolution layer filters, how the parameters are calculated, blah blah blah, everything. So you can design any architecture like this way, VG16. Now you may not be able to design the ResNet architecture because you see whatever we are doing here in the architecture, this is like sequential, right? Our function name is sequential now, TensorFlow te.
Yes, sir.
Yes, sir.
So in TensorFlow we are using creating a sequential model. So we are using built-in function like MATLAB. We are using some built-in function. Now this is like for your work sequential is enough, but if you want to like design much more smarter architecture like the ResNet, different architecture, you have to go to a little bit like little bit modified one. You have to have functional programming, you have to have some idea of functional programming. Then you have to need class, পাইথন ক্লাস পড়ছিলাম মনে আছে? আমাদের পড়াইছিলাম পাইথন, ভুলে গেছি, আমাদের না আগের ব্যাচে পড়াইছিলাম। So Python class. So in those things, you can actually design your this kind of sequential network by yourself. Okay, using this functional programming and Python class, you can actually design your own architecture in your own way, just like you have in ResNet, different architecture. Or let's say Inception. You see, the Inception network is very different, and it is very difficult to, just not possible using sequential. You cannot create the Inception architecture. করা যাবে sequential এ?
না, স্যার।
করা যাবে না কেন? কারণ ইনসেপশনের ক্ষেত্রে আমার কি আছে, ওয়াইডার নেটওয়ার্ক, রাইট? মাল্টিপল স্টেপ আছে, মাল্টিপল স্টেজ আছে এবং ওয়াইডে আছে। আমার কারেকশন গুলো কিন্তু সব
Multiple
সিকোয়েন্সিয়াল না। So
Parallel.
there are other ways to create those things, but you don't need it for your course like this way. For you don't need those things. For our sequential, for our purpose, sequential is enough. Okay. But now I just want to show you one thing, that this CNNs, these ones, like these pre-trained networks, what you have seen, VGG or ResNet things, these are called pre-trained models. We can use these pre-trained models because they have already been trained on the inception, right? Sorry. They have been trained on the ImageNet dataset. ImageNet data, they are already trained, and the weights they have learned, this is available in TensorFlow. So we can use this one. Okay, we can use the weights directly, use these pre-trained models to make prediction, see how they are actually performing. Okay, is it clear what I am trying to say? So we want to use these pre-trained models, okay, to see how they actually make how we can actually use them to make predictions. Okay, we are not going to train anything. So when you're not training anything, we are just making prediction, just like we made prediction previously in lab 1, last one. We saw whenever we train our output and train our model, we can actually make prediction. Similarly, we want to make a prediction using these pre-trained models without training. So let's look into that one. আচ্ছা, is it clear? Is it visible? আচ্ছা, now দেখা যাচ্ছে?
Yes, sir.
So application না, হ্যাঁ। So TensorFlow keras.application, you can see here all the models are actually stored. Okay. All different models, they are actually stored. So and this module you can see your mobile net, ResNet, VGC16, VGC19, exception. You already know these names. So let's say use the VGC16. So I import it from TensorFlow.keras.application.vgc16. এই যে আমি VGC16 এ চলে যাই, This is my VGC16 overview. So from this VGC16, I want to take this one, this VGC16. So from this VGC16, I import this one. Okay. So this is my model one. The architecture is already there. Okay. And you can directly load it and you can see this is your model architecture. I have not coded anything. I'm just using the VGC16 architecture. Okay. And if I took the summary, you can see this is the summary. What is the input image size? 224 by 224. So when they design the model, they design it for this input image size. So you have to, when you want to test the model on a separate image, external image, you have to make the image size কত করতে হবে? কত করতে হবে?
স্যার কোয়েশ্চেনটা আবার বলুন।
224 করো।
So our VGC16 is trained using an image of 224 by 224. So when you want to use the model to test on a separate image, on external image, what should be the external image size?
224
224, same size হতে হবে, ঠিক আছে? If you look at ResNet, it is trained on 227, I think, a little bit different. So when you test on a separate image, you have to make the image 227 by 227 like this. Whatever the way the model is trained, okay, you are using what exactly the same one, same model. That's why you have to follow their rule, however they actually did it. So you can see this, and you can see there are more than 100 million here. So there is like 138 million parameters, and you can see 527. Okay, and all of them are trainable. There is no non-trainable parameters here. Why? কেন নাই? কেন নাই?
বেস্ট
Hello?
নর্মালাইজেশন নাই।
হ্যাঁ, এখানে there is
Best
no best normalization here. I think best normalization was proposed in 2015. VGNet was 2014. Okay, so best normalization came after that. So that's why you don't have best normalization here. It was proposed after that. Okay, so we can see from the summary the input image says eto. You can check the documentation to see how everything is actually is done. Now,
স্যার এটাকে অলসো আরজিবি ইমেজ করে নিতে হবে, রাইট? যদি গ্রে স্কেল ইমেজ
yeah, of course, RGB. So I'm reading an image, so import image for classification. Okay, so PLT, that is actually matplotlib. You can use the matplotlib to read an image using the IMRead, same as MATLAB. Because MATLAB and matplotlib actually the same thing, similar way. So okay. So what is the image shape? Size কত? Imager 200,000. ঠিক আছে, 2048, 1691. That's like a high resolution image, right?
Yes, sir.
Very large image. Okay, you have to make it into 224. Acha. So using IM show, you can see the image. So this is the cat, just upside down. So it is a bit difficult to capture. Why? কেন difficult to capture বলো?
এই যে স্যার বললেন আপসাইড ডাউনের জন্য।
Yes, it is upside down. Normally when you train, you can see most of the images we place it like a standard picture, but when you have this upside down, it makes some problem. We're testing it. What is the solution to this problem?
Data augmentation.
Yes, data augmentation. But here we are not doing any data augmentation, right? We are just using the train network that the VGCnet, they actually did it. They actually gave it. We are using that one. Acha. So you can see I have this load image function, TensorFlow.class load image. And this one, when you have this one, there is a additional parameter target size. Okay. So using this inside this TensorFlow function, you have this additional parameter. So you can fix the target size the way you want. So I have made the target size here 224. You can see now it is saved in ICAT. So the image size is now 224 by 224. So it has been reduced. The size has been reduced to the size that we want to test or visit a model. আচ্ছা, so ইমেজটাকে আমরা সাইজ রিসাইজ করে ফেলতেছি। আমরা কিন্তু ক্রপ করতেছি, we are not cropping the image, we are just resizing the image, okay, making it smaller. আচ্ছা, one other thing, when you are training this, when you want to test this one, so you see whatever the image, like they are pre-processing, you see this function, this VGG16, when they are when you are trying to use a separate model like additional model, built-in model like this way, whatever the pre-processing they actually went through, I need to do the same for our image, for the external image. Because like when you are using কি বলবো ওটাকে, আমরা যখন হচ্ছে মেশিন লার্নিং মডেল ডেভেলপ করতেছিলাম, ওকে, প্রিভিয়াস কোর্সে আমরা যেই যেই নর্মালাইজেশন গুলো করি, ওকে, আমরা সবার প্রথমে ট্রেনিং এ করি, তারপর কি ট্রেনিং এ যেভাবে করছিলাম সেটাই তো টেস্টে করছিলাম, তাই না? মনে আছে?
Yes, sir.
So when you are using developing a model, however you actually normalize your image and do other things on the training data, you should do the same on the test data. Okay, otherwise it will not work. There will be a version mismatch. So same thing, whenever you are trying to test it, you have to pre-process the image. Okay, process the image the way it was processed in your original model. How they actually process it, you have to do it the same way. So they have provide the function here. So we want to do it the same way. So you can see this one, pre-process input. Okay, we just do it the same way, and now you have this one. And similarly, original image safe is 224 by 3, but we have to have a 4D array. That's why I just put 1 there. Okay, dilam. And pre-process the input, it will automatically process the input the way it requires to be done. Hello. তারপর আসতেছে prediction. So when you make the predict, just like as we've seen before, we just make the prediction and you see this is the output array. Why it is so large array? এত large কেন?
10,000 ইমেজ ক্যাটাগরি আছে,
1000 1000
1000
হ্যাঁ, so you see there are 1000 different categories, so you have an array of size 1000, and among this 1000 you want to like decode the prediction. There is a function there, you can also see decode predictions. You can decode the predictions from there as well. So whatever your output is, you want to find decode prediction. If you decode the prediction, it will give you this output like this way, very simple. So you can see this is the highest prediction value, 0.47. That means 47% probability. Okay, so it is saying that 47% chance that it is a Pyrenees, great Pyrenees. Okay, then there is 18% chance that it is a Samoyed. Okay, 70% chance it is a white terrier. So these are all our dog breed. If you look at here, so this is a Great Pyrenees dog. This looks like the cat, right? Very similar to look at. কাছাকাছি দেখতে না?
Yes.
So that's why your model is actually misidentifying. It is not able to correctly identify it as a cat because of this fur and fluffiness, just like this one. So it is actually misidentifying. So it is failed. So all of them are actually dog breed. If you look at Samoyed, you already know, I think, the Samoyed breed. So this is Samoyed. Okay, so cat and dog, they actually look similar. So here your model is not able to properly identify this one as a cat. So your model is actually making it wrong prediction. But you can see this is the top 5 prediction. Okay, you can see the probability as well. None of them has the probability of like 90% sure. 47 means it is 47% sure that it is a Pyrenees dog. Okay, or 18% sure it is a Samoyed dog. So it depends. You can see the probability. Okay, so your task will be, when you actually after we finish the lab, your task will be to take your image, one image you want to, whatever image you want to test, but it should be within this 1000 category. Okay, inside this 1000, something that is false within this category. Otherwise, it will not be able to predict anything. So whatever this one, you just take your image randomly from your own laptop, own PC, and try to check what is the prediction it is giving. Okay, so that will be your task after you finish this, finish the lab, after we finish the lab. So if we share it again. So we are done with this one. So we have seen the effect of callback. We have seen the effect of pre-trained models. Okay, number 7. We want to see now data augmentation. Now, data augmentation topic, this has been covered in section B. I think section A and C has not been covered yet. So the data augmentation is just like I said a little bit earlier. We want to, when you have like a small size data, like you have only 1000 images. usually this small size image is not enough. Okay, not enough to train your model. You need more images. Also, you need variation in the image. Like the image can come from, like if you have a cat, it can come from different ways. It can be upside down, it can be rotated, cropped, different ways. So when you training your model, you should actually have some variation. Same image, but different variation. You should actually add those things there. Then your model will have more image to train. Plus, it will also be able to detect different variations in the image. So that's why data augmentation is necessary. I'll discuss more in the class. Now here in the lab, we want to see how this data augmentation is actually done. Okay, any question? Acha, here so at first we'll actually try to apply our model on a real world data set. Okay, so this is the data set. Kaggle. So so cats versus dogs, and you can see there are কতগুলো image আছে? আচ্ছা, so let's go back. So this model, this one was trained in Kaggle. Okay, so when you have the data stored in Kaggle, you can actually directly train it from there. Okay, you can directly train your model in Kaggle. It will be easier. Kaggle also have GPU support, but it is not very good. It sometimes gets slower, I think, because when I am running the second part, GPU actually was getting very slow. আচ্ছা, যাই হোক, it took a, when you are now, so when you are working on real world data set, you will see, especially with a small, a very moderate size, even with a moderate size data, it will take a long time to train. So you have to give it like 1 hour. So do some other things when you train. You cannot just do it 1 minute. Okay. So when you are training your CNN, things like that, you have to give it long time to train. Acha. So first, let's look at it, our model, whatever we done. So this one, I think this one. So this is like a standard. You have your training, you have your callback. After this one, you train. So that's like your standard CNN architecture. We'll try to use that one for our next purposes. Acha. Now, so first of all, this will be provided to you by Kaggle just to uh, take the input, just to fix the input, whatever the input you are doing. And then you have this, it is just random, I'm just input করতেছি now, visualization. So the original image that you have, so let me show a little bit. So if you want to train your model in Kaggle, you just have to go here, see this new notebook, you just click on it here, and they will provide you with this one. Okay, a separate notebook, and you can see, is it visible?
Yes, sir.
Achha. You see there is the input, so you don't have to upload anything here. If you want to train this one in Google Colab, so you have to store the data in your Google Drive first. Then you have to mount the drive in your Colab. So if you are training in Kaggle, you can directly use the input. Okay. Here also you can see accelerator. You can see there are other, it also supports some other GPUs. You can try to use some other GPUs when you train. First write your code, everything. Then when you are training, then just start your GPU, because they have some limitations. Otherwise, your model, if you are just wasting your GPU, that is useless. Achha. So first you run it. This one is, you have to run it. Then you actually start coding. And it is the same thing, just a little bit different. We'll see. Achha, now, okay. Now one thing you can see, if you click it here, you can see this is a data set. This is the pet images. If I put it here, this is the cat. and then these are the images. Okay, this is the directory. And if you copy it, you can copy the link. This is the path. And this is the path. Okay, this is the path I just copied from there. Okay, so this is the path. And you can actually see what is the image in that path like this way. So load image from this one. So this is your image, the image of a cat with a hand. Then you have another one. This is the image of a dog. So you can see these images are like very real world images, right? Another dog, very real world images. And what is the size of the image? Image size কত?
327 327 ভাই
327 by
500
500.
500
Now, directory. See, one thing you have to be careful when you are actually working with real world data. So previously, so far, we actually just use the data that we are located in TensorFlow. But when you are working with separate data, you have to take care of the directory first. Okay. So what we want to do here, something like this. Actually, let me show it here. So the directory is something like this. So this is the data that is actually provided to you, okay, in Kaggle. So Kaggle dataset. What do you want to do? You want to, so data means এখানে কিন্তু catও আছে, dogও আছে. Cat, dog, all the images are actually put here. আচ্ছা, what you want to do in this original directory, you want to create two other directories. One is your training directory, another is your testing directory or validation directory. Okay, you want to do it like this way. Acha. And here, whatever the cat is, you want to take like 80% of cat images, put it in this directory, and 20% of cat images, put it in this testing directory. Same thing, 80% of the dog images, you want to put it in the training, 20% of the dog images, you want to put it in the testing. Is it clear?
yes sir
So this is what you want to do. So your origin, you see, this is not done. Sometimes that will happen that this is not done. You have to do it by yourself. So you have to fix all this kind of category. You have to fix this kind of directory. So first we want to create this training and testing directory. Then join this path. Then take the cat images and put it here. Take the dog images, put it here. Take cat images, put it here like this way. So there is operating system like a library. And there are some functions like make directory, mkdir. Okay. So these functions actually let you create new directory wherever you want. So you will see. Don't worry about this one. You can just copy it and search it, and you'll find all the codes there. Now, one thing, this is working directory. When you work with images here, so you'll see this is the input, and they have not separate the training and testing there. So you cannot directly modify the input. So you have to create a working directory for your code, only this one. So that's why I have first created a working directory. Then I have created new directories, training and testing. And training এর মধ্যেও আমি দিছি cat and dog, testing এর মধ্যেও আমি দিছি cat and dog. Okay, just to put the cat images here, dog images here, like this way, like folder. তুমি folder create করো যেভাবে, the way you create folders in your laptop, you are doing it same, just by using code now. Okay, so make directory, that is, then there is a function. I copied it from one of the sources. Okay, you can just copy it fast. It is just doing this split. Whatever the original directory was, it is just taking the data from there and just placing it into dog and cat training and testing force 20%. So this is the cat directory, testing directory. You can see that split size is 80%. So now you have in the training directory, you can see there are 10,000 cat images, 10,000 dog images. In the testing directory, there are 2,500 cat images and 2,500 dog images there. Okay, is it clear? Any question? Any question?
স্যার জিনিসটা ট্রেন টেস্ট স্প্লিটের মতো রাইট ওই আগে যেটা করতাম এখন জাস্ট
Train test
ডিরেক্টরি ইউজ
split.
করে করতেছি
Train test split, but you have to do it for images. So you have to do it using directory. You have to just do it like this way. You cannot do it directly. Acha. So now, if we move a little forward, so data pre-processing. Now, previously, you see, we did not actually, we just did this kind of thing, just divided by 255. Why are you dividing it by 255? You বলতে পারবে?
স্যার নর্মালাইজ করতেছি পিক্সেল
255 কেন?
The 256 values আছে in total binary.
Yeah, the images actually comes in the UINT8 format. Okay, UINT8 format means there are 256 shades of grayscale image. So there are 256 shades of white. Okay, so that's why you are multiple. So maximum value can be 0 to 255. That's why I'm dividing it by 255 to normalize it within 0 and 1. Acha. So we'll see when we want to do this kind of data augmentation, things like that. We need something. We don't want to do it manually. So there is a function that is called data generator. Okay. Inside this TensorFlow, there is a function called image data generator. It will do that for us. Okay. We'll see this operation, that data augmentation operation, a little bit later. For now, let's work with this data generator. So image data generator, you can see right now we are just scaling the value. So whatever the image you have, all of the images will be rescaled like this way. And then you are just flow from directory. Whatever my training data path was, I'm just getting all the images from there and saying that the target size should be this 224 by 224. Okay. So here the original image size was, I think, 327 by 500. So different. We want to make it the size we want. You can change it. I am just using 224. That's like your VGG net. You can make it 256, whatever you prefer. That's up to you. And I'm using batch size of 128 to make it faster. Acha. So I have this train data generator, test data generator, Gallo. Okay. Then this CNN architecture, this is the same as what we actually did before. I have the max pooling, dropout, batch normalization, all of those things. But check this one. Okay, sometimes you see, now I'm using an stride of 2 because I have original image size is like 224. So we have large images. So you have to step by step, you have to reduce the image size. Okay, so step by step, I'm reducing the image size. And the last size, I have 7 by 7. Okay, and now you can see the total number of parameters is like 36 million. Okay, 36 million images are there. Sorry, 3 million, 36 not 3 million 63,363 36 লক্ষ, হ্যাঁ 3 million images are there, 3 million parameters are there. আচ্ছা আর কিছু বাদ দিলাম? ওকে, হ্যাঁ, one thing যেটা বলতে চাচ্ছিলাম, so when you are doing this way, like image, other size images, make sure you take care of this level. Okay, so see, you have like, when you flatten, you have 12,554. In the next step, I made it 256. I should make it a little bit higher than 256, but it will take a long time to train. That's why I reduced it. So make sure you actually check off this one. Otherwise, it will take a huge time to train. If you make it like 2000 at first, you will see the number of parameters will increase significantly because this two will get multiplied. You know how to calculate these things now, so you understand, I believe. So make sure you are careful about these segments, these portions. Also, you can also use global average pooling and see how the performance is actually affecting. Okay. And since I have batch normalization, I have non-trainable parameters. I have the callback. I have made the patient 6. Same. Now binary, because you see the last one has only one. So when you have an activation is sigmoid, when you have binary category, cat versus dog binary, we use sigmoid. When you have more than 2, we use softmax. Same thing, just the name is different. And since I have this one prediction, only one of the is enough. One of the nodes will be enough. So for 2, we can just use only one node. That will give you the probability 1 and 1 minus whatever the probability is. So same thing, train generator, fit. Epoch, some errors, and you can see, it is training. It is taking 74 seconds, like more than 1 minute to train one epoch. Okay, so it is running for 13 epochs. That means it took around 15 minutes to just train this one. Okay, and this was actually this is the second one. I removed the first one. The first one was taking 3 minutes around. Okay, then I actually increased the batch size, reduced these ones, and modified a little bit. So now you can see it is taking 1 minute or more than 1 minute to train per epochs. So you have to take care of the training time. And if I look at the performance, you can see it is now around 90%. The training accuracy is like 98%, and the testing accuracy is 91%. So it is overfitting a little bit, but since I stopped training, it is not overfitting. So if you keep running it for 50 epochs, you can try it. If you keep running it for 50 epochs, you will see whether the validation accuracy increases even further or it just keeps overfitting or not. Okay. You can test it by yourself. Hello. Any questions so far? So make sure keep note of this one. You see our training accuracy ছিল হচ্ছে 98% এর কাছাকাছি and validation accuracy 90% এর কাছাকাছি। আচ্ছা। Now let's go far. Now data augmentation. How do you perform this kind of data augmentation? আচ্ছা। Okay. Now inside this image data generator, if I go here, reprocessing.image. This sign means this is actually deprecated. So they probably actually put it in another function inside some other thing. I have to check. They keep updating those things. So this is the image data generator, and inside C, however you want to augment your image, okay, all the possible things are actually provided here. Okay, you can see the description, what each and every one of them means. So for instance, brightness range, shear range, zoom range, okay. Then horizontal flip, vertical flip, you can do a lot of things. But you can see, but one thing you have to keep inside your mind, you see, when you are doing this augmentation, all the images are actually passing through this kind of augmentation. So number of images will increase during training. This will be done during training. Okay, not separately. It will not separately create new images, but it will be done during training. So your training time will increase. So if you put lots of different augmentation, the more time it will take to train. Okay, so it will increase the training time. So you have to be careful about what you are actually doing in the image data generator. Make sure you are only doing it things that is actually necessary for your image, the particular one you are working. For instance, horizontal flip, vertical flip. This is very important for your cat versus dog. Things like that. Now, we are only modifying the training image. We will not be modifying the testing image because we are just testing it. So all the training, because during the training, we are performing this data augmentation. Rest of the things, just as same. Is it clear? Any question? Question? If not, see, you can see I start training. Now you can see when you are doing this data augmentation, it is taking 304 seconds. That's like 5 minutes per epoch. Okay, that is taking a long time to train. Almost 5 minutes like this. And if you looking at this accuracy and you see overfitting হচ্ছে
না স্যার
না, overfitting হচ্ছে না। কেন হচ্ছে না?
স্যার ডাটা অগমেন্টেশন করুন।
See, when you are using this training, now the training process, during the training, your image is changing every step, many different steps. You are rotating it, changing the shape and all these things. So your training is now much better than previous things. Previously, images were on the same time, so your training was just going on and on. But now, at every step, the image actually changing. So your training is now much more accurate training. Okay, that's why your training accuracy is gradually increasing, not like শুরু থেকে একদম একবারে হাই হয়ে যাচ্ছে না। It is not like just getting higher and higher. No, not like this way. It is gradually. And just as the training accuracy is increasing, your validation accuracy is also increasing. There is a drop here. I don't know why we have this particular drop or something, but it normally you will see you will not have this kind of drop. Normally it will be like this. And some of the cases you see validation accuracy is even higher than the training accuracy. তাই না? এটা কি ভালো না খারাপ? ভালো না খারাপ? হ্যাঁ, this is better. You can see previously there was not a single scenario where your validation accuracy was better. But this is the only scenario when you are seeing that your validation accuracy is better than the training accuracy. That means your model is trained perfectly. Okay, it is trained so nicely that the validation performance is even better than the training performance. Okay, it is working better in the during testing. So that's what we want. We want the testing during testing. We want even better performance than training. So that means when you are using this kind of like data augmentation, your model will train very nicely. Your training will be perfect, and you have very little to no overfitting. Okay, so this is a very perfect curve you are actually getting, except for this region. So you can test your own model and see different things. You can test on other data sets as well. Acha. Yeah, so or কিছু. Okay, so any other question? Any question from this data augmentation? Any question? Okay, so I believe that this is clear to you. So try shot. So data augmentation is done. So I believe with this data augmentation, you know the basic CNN architecture, whatever you need for training a CNN model. You know all of those things. There is one other thing that is remaining, number 8, that is transfer learning. Okay. Unfortunately, I could not finish training this one. But I'll provide you the notebook after finishing the training portion, but I can show you. So applications. So the transfer learning topic, since section C has not actually, it is not covered in section C, so এটা এখন পড়েও লাভ নাই. So I need to cover it in the theory first to actually explain those things. So I'm not going to describe now. Section B already know those things. So let me just give you a little bit of, you can see include top কি দেওয়া true. মনে আছে এটা কি জিনিস সেকশন বি থেকে?
কোয়েশ্চেনটা আবার বলবেন?
What does this include top means বলতে পারবা? ক্লাসে পড়াইছিলাম।
So top is the last layer, sir.
Yes, the top means the last layers. Should I include this one or remove that one?
Sir, remove that one.
We will remove the last layers and
Yes. So you
we
can
will
see.
freeze the first.
Yeah. So you can see when we are using this one, right? For this person, when you are using this train network for predicting, that is the time when you want to use the whole architecture. That's why include top is true.
স্যার
But when
আপনি
you
কি
use,
স্ক্রিনশট দিয়েছেন?
oh sorry. স্ক্রিনশট দেই নাই?
ট্যাবের স্ক্রিনশট দাও।
না তাহলে হবে। তাহলে কি বলতেছি? Here, আচ্ছা। You can see this one.
Yes, sir.
আচ্ছা, VGG 16. So you can see here, include top is equals to true, right? Weights equals to image net. That means it is trained on the image net. That is the weights that you have. And include top true means the last layers, like the last artificial neural networks, the last dense layers is actually included. Why it is included? Because we need it for testing, the one that you actually saw, testing this one for prediction. But when you're using transfer learning, we don't need this include top. We want to remove that one because that is particularly for prediction. So we have to make this include top as false. Whether to include the 3 fully connected layers at the top of the network. No, we don't want that. We just remove it. Achha. So if I do this way, I will just remove this one during transfer learning, and we'll just use the rest of the architecture during our transfer learning process. We use the weights. Then there are 2 ways to do it. I'll show you in the notebook that how to actually do those parts, how to use this architecture to do the next of the thing. Next of the thing is just as the same. Okay, just only this portion. So that will be your transfer learning. I'll just provide a notebook to you. Okay, and if I can, we'll actually discuss a little bit on lab 3. Okay, but I want to finish this one as quickly as possible because we have some other things to share. Now, last topic is the segmentation. Okay. Now, image segmentation. So in the classroom, we already talked about section B. We already talked about segmentation. And I think I have showed you this notebook as well. So there are different ways to perform this kind of segmentation task. One using image processing. Some of them are using image processing techniques like region-based, pixel-based, edge-based, and some of them are using CNN architecture, convolution neural, that are the more later ones. Okay. Deep learning is included to perform this image segmentation automatically. So you have some architecture like UNet, SegNet. Okay. So those architecture is particularly developed to perform image segmentation automatically. But here, at first, using MATLAB, it is very simple, just very simple one. We'll see how to perform this image processing, image segmentation using MATLAB. So this is not automatically, you have to do a little bit manually, then you can actually automate the process. Okay. So you can see here, I have discussed these things in the classroom. So for section C, those who are here, I'll discuss this in section, I'll show it again in the classroom so that you can understand properly. So in image segmentation, whenever we have an image like this, for instance, this image, you can see here, this is the like a wall, and this is a crack in the wall. I have one crack like this way. So I want to segment this portion in particular. I have to segment it into what is the wall portion and what is the crack portion. So segmentation is this. We have to segment the original image into two different parts like this way. So this portion, this is called segmentation, a very simple segmentation. We'll use it in different other regions, other tasks as well, we'll see. For this one now, so you just input the image. This is a crack image, you input the image, and I will provide, I have I have one lab manual created using digital image processing for third year signal processing lab. I'll share it with you as well. You can actually understand how to load an image, how to work with an image using MATLAB. If you actually need this knowledge, if you are not, you do not have that knowledge yet. So you see, I am taking these images, I'm converting those things to grayscale because whatever the processing that we need, we want to convert it into, we want to do it in using grayscale images, not color images. Then, so this segmentation can be done in using thresholding. The operation is called thresholding. There are different thresholding operations. One is like the global thresholding that will find one value. Based on this value, it will segment the image into two different sections. I'll discuss those things in details in the classroom. So don't worry if you don't understand. Some of you don't understand properly. So you see, when you do it this way, this is the left side image. Now we are segmenting it into foreground and background. So in one side, this crack, this is the whole black portion, and these are the white portion. And we have found, we have done this using the pixel value. And what is the pixel value? You can see this is the pixel value, 115. So any pixel, so these are the grayscale image values. So any value that was less than 115 was marked as 0. So that's why it is black. Any value that is higher than that is marked as white. That's why this portion is white. So you can see this is now in this image, you can see what is the crack portion. Okay, that's how your image is segmented into two different types. Also, the image, you can see this is how we actually segment the image. Also, this one, like this way. So this is the global thresholding. So this is performed using Otsu's method. This is a method that actually calculates to calculate what should be the value, pixel value based on which we want to segment our image, segment our images. You can also do it using adaptive thresholding. Okay, it will actually find different values for different regions. Okay, I'll talk about these things again in the classroom. So you can see the code here. This is very simple. You have this function I am binarize. I believe you already know how to use MATLAB properly, so I am not repeating these things. And you can also do it manually. See, there is this slide button. Using this control numeric slider, you can create this sliding option and fix the value by yourself. You can check different values and see the output. Now, also multi-level thresholding. For instance, this is this one. If you look at this image. Okay, so this is the image of an arm X-ray. Okay, I was not able to show it in section in the classroom. So you see, when you have this kind of arm X-ray, you want to separate the flesh, the muscle, tissue, bone, everything separately. So there can be multiple thresholding required, multiple segmentation. You can also do those things using MATLAB as well, this kind of segmentation technique. So now you can see you have this flesh option, the flesh, then muscle, the bone, everything segmented out. Okay, using multi-level thresholding. If you just look at the code, it is very simple. I don't think I need to repeat it. Okay, and you can also test those things in a random image like this way. Okay. And if you look at these apps, MATLAB actually provide different apps like image processing and computer vision. I have discussed some of the things in the lab manual that I'll provide. Okay, digital image processing lab manual, and you can see this image segmenter app. Okay, this is something that you can use. Okay, sometimes in X-ray image, I don't know I'll be able to cover those things or not. In X-ray image, okay, we'll need this kind of segmentation. Okay, you can see from this one, your image X-ray image will come in this format. So if you want to work it properly, you need to segment it so that you can visualize everything very clearly for further processing. So if you want to do it like this way, like basic understanding, so image segmenter app is very valuable there. Also, you can see here DCOM browser. DCOM is another file format, just like JPEG image or PNG image. DCOM is a file format that is used for MRI image. Okay, MRI image, volumetric image. So if you want to, when you want to work with MRI images, I will try to keep one image, one lab based on MRI image processing. We'll use this DCOM browser. Okay. So there are different options. You can actually try to take a look at it. Just try to understand how to perform this kind of segmentation using MATLAB. Okay. Once you do it for one image or two image, see what once you do it for one image and two image, you can just automate the process. Okay. MATLAB also have a, you can see batch processor app. So yellow. Image batch processor is it image batch processor. So whatever you do, like this kind of segmentation for one image, you can automate the process for 1,000 different images, 100,000 different images using image batch processor app. So you are doing it manually for one or two images to understand how it is, what is the actual, what should be the correct one. Then you can automate the process for all the images this way. So this is the image segmentation task. I'll provide the lab manual to you. If you have any questions, you can ask me there. Okay. Anything else? If you have any questions, let me know. So we are done with today, or lab 2. For transfer learning in particular, so for transfer learning, there will be another notebook. I will upload it in your Google Classroom. I'll try to train it. It takes a little bit time to train. So I upload the notebook later. Rest of the things are covered. So with this one, with this transfer learning, we'll be done with our basic CNN architecture. Okay, basic CNN architecture, and we will have a open-ended lab. You will have open-ended lab. I think I will just give it to you as a homework probably. Okay, you will have to apply all of these things in one of biomedical imaging tasks. Okay, either X-ray image or other images like this way. Any biomedical imaging task, you will have to apply all of these things up to transfer learning for this one and try to see how you can actually perform, whether you can actually build a model that performs well in biomedical images or not. Is it clear? Any question? Any question? বলো কোন কোশ্চেন আছে?
স্যার যখন বেসিক স্ট্রাকচার গুলো বানাই
হুম।
তখন হচ্ছে মানে ফিল্টার সাইজ গুলো যদি আমি র্যান্ডমলি দিই তাহলে হচ্ছে মানে অনেক সময় কাজ করে না। মানে এটা কেমনে বুঝবো? লাইক ফার্স্টে যদি 32 দিয়ে স্টার্ট করি, তারপর 64, ধরেন আরেকটা 64 দিলাম, তখন হয়তো কাজ করতেছে না।
না,
মানে এই
করবে,
জিনিসটা কখন
64 দিলে কাজ করবে, সমস্যা নেই। ফিল্টার সাইজের সমস্যা না। আরেকবার বলো তো।
মানে স্যার মানে ধরেন আমি একটা লেয়ার বানাইছি, ফার্স্টে ধরেন হচ্ছে 3x3, 32, তারপর ধরেন হচ্ছে 3x3x64, তারপর
হ্যাঁ,
3x3 আবার আবার 64 দিলাম, তারপর পরেরটা হচ্ছে 3x3 ধরেন 128 দিছি। মানে র্যান্ডমলি আমি চাচ্ছি হচ্ছে স্ট্রাকচারটা বানাইতে, তো
হুম,
তখন স্যার অনেক সময় কাজ করে না। মানে
না,
বলে কি?
আচ্ছা, তোমার তোমার যে ফিল্টার সাইজ আছে সেটাতে কাজ করার বন্ধ হওয়ার কোনো কথা না। দ্য থার্ড ডিমেনশন যেটা, দিস শুড নট বি দ্য রিজন। দ্য রিজন ক্যান বি দিস। এটা কেন রিজন হতে পারে? সি, তোমার ধরো তোমার ইমেজ আছে হচ্ছে 227,227,227 and something here 3. If you try to put the next layer, if you try to half it, like if you are doing max pooling, and you cannot like এটা যেহেতু বিজোড় সংখ্যা, এটাকে কিন্তু তুমি জোড় বাঁধাতে পারবে না। So if you are using a 2x2 max pooling size, it should give an error here. বোঝা যাচ্ছে আমার কথা?
জি স্যার।
So you should have a 3x3 pooling layer then it will work. So you have to have 8 সাইজের মানে উল্টাপাল্টা হলে তোমার ইরর আসবে, নট দিস থার্ড ডিমেনশনে কোনো ঝামেলা হওয়ার কথা না আমার যতটা আমি বুঝতেছি। ট্রাই টু চেক করে দেখি হচ্ছে আসলে তোমার থার্ড ডিমেনশনের সমস্যা আছে নাকি এইখানে সমস্যা আছে। এইখানে তোমার সমস্যা হতে পারে, তুমি এখানে ম্যাচ করতে যায় তোমার ভুলে গেছে। সো ইউ উইল সি লাইক ওরা যখন হচ্ছে যে ইয়াগুলো ইউজ করে ওরা কিন্তু এখানে ম্যাচ করে, আমিও কিন্তু ম্যাচ করতেছিলাম। আমি যখন 224 নিচ্ছি প্রত্যেকটা ইয়াতে কিন্তু আমি কিন্তু ইভেন্ট নিয়ে কাজ করতেছি। ইভেন্ট নিয়ে কাজ করতে এই জন্য কারণ যাতে করে আমার এই যে ইমেজ মিসম্যাচের সমস্যা না হয়। তুমি যদি অড নিয়ে কাজ করো তোমাকে একটু কেয়ারফুল হতে হবে যে আমার কোথাও ইমেজ সাইজে মিসম্যাচ হয়ে যাচ্ছে কিনা, বুঝা গেছে?
হ্যাঁ
কারণ
yes,
তোমার
sir,
যদি 221 থাকে, একটাতে যখন 1 থাকবে তখন কিন্তু 2x2 ফিল্টার আর কাজ করবে না, তখন কি করবে সেটা সম্মত আলাদা করে মেনশন করে দেওয়া লাগবে। ওকে, এনি আদার থিং?
no, sir.
কারো কোনো কোশ্চেন? আচ্ছা, প্লিজ রাইট ইউর আইডি ইন দ্য চ্যাট। ওকে, সো উই আর ডান উইথ টুডে। Yeah, I'll provide the MATLAB